Hey guys, I'm gonna go over most of the things. What I need to make sure to go over also is um, at the end, I'm gonna go over the ellipses. I think I'll have to make up questions for that, but I'll show you how that works out. Or I just go over it as if it's notes, who knows. But first, let's go through this. We're at 4.5, 4.7 from the last video. We're gonna talk about graphing these things. So graphing these things, 3 sine 4x minus 2. In general, you have a, whatever your trig function is, bx minus, I don't remember if we use c or we use k. I'm going to use k, but it might have been c the whole time. If you see other videos, it might be c. So a, it tells you a couple of things. One, a tells you how much it goes amplitude-wise. And it'll tell you if it's flipped over, if negative. If negative, you flip it vertically. B will affect your period. So it is going to be 2 pi over b if it's sine and cos, and it'll be pi over b if it's tan, including the reciprocal. So sine, cos, cos you can't, secant, tan, and cotangent. And then the k value or the c value is your vertical shift. Not only that's going to affect where the midline is, it'll affect what your range is. All right, let's talk about these. First off, sine, 3 sine 4x minus 2. In this case, my amplitude is 3 because my a value is 3. My period, it should be 2 pi over 4. So in this case, it's pi over 2. My vertical shift, in this case, it's down 2. So I'm going to go down 2, so it's down 2. I guess I could just put it there because it's negative 2 is my k value. My domain, for sine, I could plug in anything. So negative infinity to infinity, that's fine. My range is going to be from my amplitude up and down. So it's going to be what my midline or my vertical shift is. So my k value plus or minus my amplitude, my a value. So negative 2 plus 3 is going to give me a positive 1. Negative 2 minus 3 is going to give me a negative 5. So in this case, my range is going to be from negative 5, hard bracket in this case because I actually reached negative 5, to 1. This one, tan plus 3 for the amplitude. Remember, tan kind of looks like this, and then there's like an asymptote, and it looks like this. Now, the amplitude in this case really is not applicable. So if you put 1 or not applicable, it could be either answer on the multiple choice or undefined, or I probably won't ask for the amplitude of a tangent just to minimize confusion. The period is going to be b value over pi, but in this case it is just 1, so pi over b is just pi. Vertical shift, that's up 3. My domain, in this case, my x cannot equal every asymptote that occurs. So every asymptote that occurs, it happens at every pi over 2. So it's going to be uh, n pi plus pi over 2. Because it happens at pi, it happens at negative pi over 2, it happens at negative 3 pi over 2, it happens at positive pi over 3 pi over 2. So it's every n, and n representing any number. So any whole number, so 1, 2, 3, 4, 5, pi plus pi over 2. My range in this case, it reaches from the bottom to the top, so negative infinity to infinity. All right, give the parameters and graph this function. So cosine in this case, the amplitude is 2. The period, it's going to be, it's the b value, so pi, 2 pi over 2. So in this case, that's going to end up being 4 because the pi's cancel out and the 2 goes on top, so that's 4. So it's going to be 4. The vertical shift, no vertical shift, so 0. Domain, again, from all reals, so negative infinity to infinity. The range is going to be from the amplitude from the midline, so k plus or minus the amplitude. The midline is 0 in this case, so it's going to be from negative 2 to 2, hard brackets. Not graphing this, something graphing like this, you're going to put, I know it's going to go up and down 2. I know at each period, the whole period's 4. So I'm just going to count it down 3, 2, 1. And then over here is just the reverse. -4, -3, -2, -1. And here's 0, of course. Here's 2 and -2. And in this case, this is a cosine. Cosine, if you know, well, let's do this. Sine, it starts at the middle at 0, and you make your wave like this. Cosine tends to start at the top. So it's going to be top here, and then like that, and like that. So in this case, I know it's cosine, so I'm starting at top. So top, middle, bottom, middle, top, middle, bottom, middle, top. So I should make a wave that kind of looks like this. Of course, you could type literally this in your calculator and look at the wave. I would recommend you click to make sure you can see it well. You could click zoom, the button zoom. It's in the middle right underneath the screen. And there's a couple options. You should see for zoom trig. It zooms purposely so you can see a trig function easily, okay? Over here, sketch 2 periods and graph cosecant 1/2 pa x. You might have it where it's like cotangent or something. I don't remember which version you have. So if your paper's a little different, don't worry about it. Don't go crazy. And you know what? Why am I wasting time? You're not going to graph cosecant. You're not going to graph cotangent. Just know how to graph sine and cosine, okay? Let's move on. Next one, find the exact value of the given value. So sine -1/2, that's the same thing as me asking sine of what degree, well, sine of what degree gives me a half. That's the same thing. So I got to think of either my unit circle. So I'm looking at where it's 3 comma 2 comma half, because remember, sine is the y value. In this case, these happens at uh, 30 degrees. So in this case, sine of half is 30. In this one, I want tan of 1. So what does tan of 1 mean? So that's probably at a 45-degree angle. So, well, let's say you didn't know that. You got to make a triangle. You know tan is opposite over adjacent because toa, tan, SOHCAHTOA. So, ka, toa. So it's opposite over adjacent. So in this case, it's 1. Technically, the fraction's 1. So 1 over 1. You can figure out what this guy is. Hopefully, you figure out eventually is root 2. So now I need arc sine. So I need to use this triangle to find sine. In this case, sine is going to be opposite over hypotenuse. So in this case, it should be 1 because this is the opposite over the hypotenuse, which is root 2. But you got to fix that up. So that's going to be root 2 over 2. If you notice that this is at a 45-degree angle, you could use that to your advantage also. Next one, again, you're going to make a right triangle that fits with this situation. So here's your right angle, or right triangle, where sine of -1 is 3/5. So the opposite is 3, and the hypotenuse is 5, because it's SOHCAHTOA, so opposite of hypotenuse. So in this case, I could figure out this is 4. And in cotangent, that's adjacent over opposite, because if tan is opposite over adjacent, then cotangent should be the reciprocal, adjacent over opposite. So adjacent over opposite, so adjacent is 4, the opposite is 3, so your answer is 4 over 3. You're hopefully seeing a key here. Arc cosine is the same as cosine -1. So cosine -1 is going to be 5 over 13. So right angle, theta, adjacent 5 over hypotenuse 13. This is going to be x, or I don't need this to be x. This is 12 if you figure out the Pythagorean theorem. Tan is opposite over adjacent, so 12 over 5. Cool. That is done for that one. Let's go to chapter 5 here. This is the trig identities. Tough for some people. So cotangent, I could rewrite it as cosine over sine times sine. Cross these out. That means it's just cosine x. For this one, 1 minus cosine squared x, hopefully you can see that it's become sine squared x. times cosecant, which is 1 over sine. Well, I could reduce this by 1, and I could reduce this by completely. So it's just going to be sine x. In this one, secant is 1 over cos minus sine over 1 times sine over cos. So in this case, I could rewrite this as 1 minus sine squared. And because the denominators are going to be the same, over cos. Well, 1 over sine squared is cosine squared over cos, which if you simplify is just cos. Cosecant is 1 over, well, actually, here's the better move first. This is already in a fraction, so why make it into more fractions of fractions? Let's put this over 1, and I'm going to times this by cosecant, and I'm going to or I don't need to times that side by cosecant. It already has cosecant. That's my fault. I need to times the right side by cosecant over cosecant. So this is going to be rewritten. There are multiple roots to the same answer, so as long as you get to the same answer, I don't care how you take it. So cosecant squared minus cotangent squared x. They're both over cosecant. So I can make it one fraction. Cosecant squared minus cotangent squared over cosecant. Hopefully you can see that this will eventually become 1 over cosecant. Flipping 1 over cosecant is sine. So your answer is sine. Over here, tan minus secant minus cosine. In this case, I want these to combine, so I'm kind of forced to do a fraction and a fraction. So tan, actually, I guess I'll make the top into a fraction too. So I'm going to do sine over cos over secant, which is 1 over cos, minus cos over 1. To make the bottom matches to each other, I need this to be cos over cos. So I'm going to rewrite that as sine over cos over, this is going to be 1 minus cos squared over cos. So because it's 1 over cos, I could cross out because they're both on the bottom of their fractions. So I'm allowed to cross them off to each other. Or you could do keep, change, flip. I don't really care. So 1 minus cos squared. Hopefully you see 1 minus cos squared is sine squared. Sine squared over sine, reduce that. That's 1 over sine, which clean out is cosecant. This one, number 6, cosine to the 4th power minus 2 cosine squared plus 1. In this case, I need a factor. So it's going to be cosine. You could think of it as x to the 4th minus 2x squared plus 1. It's the same factoring. So it's going to be cosine squared x minus, minus 1, all that squared, right? Because this would be x squared minus 1 twice, so that'd be squared. Well, cosine squared minus 1, that is sine squared, so sine squared. So sine squared squared is sine to the 4th. Again, there's multiple roots to figure out the answer. All right, proving trig identities. To prove a trig identity, you got to look at the, you got to figure out the work. Usually, it's easier to make bigger things into smaller things, so I'm going to try to make this into that. So on the right side, I'm seeing I have cosecant, I see cosine squared, and I see plus sine. So I'm going to do cosine squared over cosecant, which is sine, when you bring it to the bottom, plus sine over 1. In this case, I need to multiply this by sine over sine, so I could have a common denominator. So cosine squared plus sine squared over sine. Then cosine squared over sine squared is 1 over sine. And then 1 over sine is cosecant. So that matches what we had over here. Over here, it's easier to make a subtraction into a division or a multiplication, so we're going to change this one. So secant, I'm going to change to 1 over cos minus cos. I'm going to have to over 1, I should say. So this guy needs a cos over cos. So it tends to be 1 minus cos squared over cos, which is sine squared over cos, which now I have what I want, actually. I don't need to rewrite it. So that's good. Over here, like I said, is easier to make the division into less division, bigger to smaller. I would say this is bigger. So we're going to work from the right side. So 1 plus cosecant squared. You wish you could say that's cotangent squared, and it's not. It is not. Remember, the original formula is cotangent squared x minus 1, or plus 1, equals cosecant squared. So if I subtract 1, that'll be cosecant squared minus 1. So I can't change the top, but the bottom I could change. So I'm going to do 1 plus cosecant squared over cosecant squared. Because they're a fraction with the denominator, I could rewrite it as two separate things. So 1 over cosecant squared plus cosecant squared over cosecant squared. Then, wait a second, cosecant squared, I could reduce that to 1. And then this I could move up into sine squared. So sine squared plus 1, which is the same as 1 plus sine squared. I know some people are thinking, Mr. Tobel, how the hell was I supposed to know that? You got to try. You got to know your tools and what you can do. I wish I could tell you, do this every time, but it's not algorithmic like that. So now I got to get this to this. It looks like the left side's better than the right. So in this case, I'm going to rewrite this as two separate fractions. So I'm going to do tan x over tan x cot y plus cot y over tan x cot y, cotangent y. In this case, these tan x's cross out, and these cotangent y's cross out. So then I have 1 over cotangent y plus 1 over tan xy, or tan x, I should say. Well, cotangent y, when I move it up, it's going to become tan y, and tan x, when I move it up, is going to be cotangent y, or cotangent x, my bad. So then that matches what I have over here. Usually I'm not a stickler of if you forget your x's or x's along the way. Like in this one, you notice I don't write any x's. But just make sure in this one you write your x or y's because they're actually significant. All right, this one, give all the answers within, is that how you spell within? Withening, whatever. From 0 to 2 pi. So in this case, I'm going to do minus 1, minus 1. So 2 cos x equals negative 1, divided by 2, divided by 2. Cos x equals negative a half. So I need to figure out what causes cos to have a negative a half. So I need in the unit circle where it's 1, 2 over root 3 over 2. That is going to be at the 60 degrees. At the 60 degrees, that is going to be, because it's negative, all students take calculus. It's going to be in these two quadrants, because these two quadrants is where cosine is positive, so I need a negative. So I need the 60 degrees that go with this, and the 60 degrees that goes over here, which is 120 and 240. The only problem is I need it in radians, because I asked you in radians. So it's going to be 2 pi over 3 and 4 pi over 3. Next one, number 4, same process. This one is going to be plus 3, and then divided by 4, divided by 4. So sine squared x equals 3 over 4. So then I can square root both sides. So sine x equals the square root of 3 over the square root of 4. The square root of 4 is 2. Remember, you need a plus minus because you're square rooting. So I need all the places where sine is root 3 over 2. That happens at 1/2, comma, root 3 over 2, or at the 60 degrees. So because that happens at the 60 degrees, and I have both positive and negative, it's at all 4 quadrants. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. All right, next one, we're going to factor this. Because we have a GCF, I'm going to take out a secant x and leave with secant x minus 1 equaling 0. So I could split and solve this. So secant x equals 0 and secant x equals 1. Remember, this means the reciprocal should be sine. But in this case, the reciprocal 0 is undefined. So this doesn't even mean anything. Where I'm going to do the reciprocal of this, which is not sine, and I apologize for people who notice that. It should be cosine. The reciprocal should be cosine. Well, it's still a problem. This is still undefined, so you can't have this. So cosine of the reciprocal, luckily for me, the reciprocal 1 is 1. So I need the cosine at where cosine x equals 1. That means it's like 1 comma 0, because cosine is the x value. So that just happens at 0 degrees or 0 radians. All right, what I'm pulling out is a test from 2 years ago that goes over a system of equations. I'm not going to do all these problems because they're slightly repetitive, but I'm going to show you the general idea. So the first thing over here is we're going to figure out what this is. Right now, it's set up for a perfect elimination. So what I'm going to do is add vertically. So negative 7x plus 4x is negative 3x. 4 plus negative 4 is 0, which is perfect. I want the y's to disappear. And 24 plus 0 is 24. So I'm going to divide negative 3 divided by negative 3. That's going to be x equals negative 8. So now I found that x equals negative 8. I take it and plug it into one of my original equations. Doesn't matter which one I plug in. I'll plug it into the bottom because it just looks like smaller numbers. So 4 times negative 8, my x becomes negative 8. Minus 4y equals 0. Negative 32 minus 4y equals 0. A little bit of algebra, you'll figure out that y equals 8. Negative 8. They're both negative 8? I guess so, yeah. So because of that, your final answer is going to be negative 8, comma, negative 8. Over here, that was elimination, what I just did. Here's substitution. In this case, right now, it doesn't look like I could eliminate it. I could rewrite it to make it an elimination, but in this case, what I'm going to do is take this one and divide everything by 2. So I'm going to divide everything by 2. So that's going to become y equals 3.5y minus 5. So now I have a y here. I'm going to plug it into the y here. And it's going to be 14x minus 4 times 3.5y minus 5 equals negative 20. Hopefully, when you distribute this and you're going to see something interesting, 14x minus 14y minus 20 equals negative 20. These cross out because they're 0. Negative 20 equals negative 20. Since you get the same number equaling to each other, this is considered all real solutions, okay? You might also see it as infinite solutions. As a side note, if you have something that ends up being like 1 equals 0 or something that's impossible, right? That would be no real solutions. So these special situations occur when you get all your variables canceled out. Let's try this one. Again, we're going to do some substitution. This one a little bit obvious because it's y and y. So I'm just going to set them equal to each other. So negative 2x plus 2 equals negative x squared plus 2x plus 7. For my safety, I'm going to bring the x's to this side so I can make a positive x squared. Or you can bring it to the right side. It doesn't matter. So x squared minus 4x minus 5 equals 0. Then over here, I'm going to multiply what multiplies to negative 5, that adds to negative 4. So x minus 5, x plus 1 equals 0. And then I'm going to split each one, so I get positive 5 and negative 1. Because I get positive 5 and negative 1, what I'm going to do is take those two answers and plug it in either to the bottom or the top. In this case, I'm going to plug it into the bottom. But remember, these are x's. So I'm going to get two sets of solution. 5 comma, when I plug it in here, negative 2 times 5 plus 2. So negative 10 plus 2 is negative 8. And I'm going to plug it into the same equation, but with negative 1. So it's going to be negative 2 times negative 1 plus 2. So 2 plus 2 is 4. So it's going to be negative 1 comma 4. So in this case, you get two solutions. And you're going to get two solutions. Kind of the reason is because you get a system of equations like that. Remember, if you get a situation that is impossible, you will get no solutions or infinite solutions. In this case, I just got two solutions because they hit each other at 2 times. Number 4. In this case, we're going to try to fix our way to make it so they could be substituted. In this case, I'm going to minus 5x on both sides. So y equals 2x squared minus 5x plus 6. And this one, I'm going to minus 4x on both sides. Y equals 3x minus 2. Again, they're equal, so now I can set them equal to each other. 3x minus 2 equals 2x squared minus 5x plus 6. A little bit of algebra. 0 equals 2x squared minus 8x plus 8. I could divide everything by a 2 to make my life easier. So it's going to be 0 equals x squared minus 4x plus 4. Hopefully you could factor this out. 1 multiplies with 4, that adds to negative 4. That's going to be x minus 2 and x minus 2. So x minus 2 squared, which means the only answer I get is 2. It's considered a double root, but I either figure out that x equals 2. Because x equals 2, I could take 2 and plug it into anything. You could even plug it into these rewritten equations. So I'll plug it into the bottom one here. So 3 times 2 minus 2. 6 minus 2 is 4. So 2 comma 4 is your answer. Over here, number 5, we're going to check how many answers this is. So again, I'm going to substitute. Probably the easiest thing I'm going to do is get y by itself. So divide by 2, divide by 2. So y equals x over 2 plus 2.5. So in this case, we're going to have to try to figure out how to plug this in. So I'm going to take the y and plug it in here. So you got to be careful, though. It's going to be x squared plus x over 2 plus 2.5 squared equals 25. So I'm going to have to actually FOIL this. If it makes your life easier, you might want to write this as 0.5x. If it makes your life easier, I don't care which way you do it. Either way, x squared, I'm going to FOIL this out. So that's going to be 0.25x plus 2.5x plus 6.25 equals 25. X squared plus, this is squared. So it's going to be 2.25x squared plus 2.5x. I'm going to subtract 25 on both sides equals you know what? You're not going to do a problem like this. Forget it. I don't feel like working too hard. Okay, 3 variable equations. These are kind of important. So in this case, you remember you need an x, a y, and a z. So because you have an x, y, z, you need to find one at a time. Lucky for me, I found 3 over here. So I know this is 3. I could take the 3 and plug it into something else. So here I'm going to plug in 5 times 3 plus 2y equals 11. So 6 minus 11 is 5, and then 5 divided by 2, so y equals 2.5. Wait, it's 15, my bad. So 15, so this is going to be negative 2. So negative 2, so y is negative 2. Since I have x and y, I could take that numbers and plug it into here. So 4 times 3 plus 5 times negative 2 minus 5 times z equals negative 3. 12 minus 10 minus 5z equals negative 3. 2 minus 5z equals negative 3. Negative 5z equals negative 5. Z equals 1. So 1. My answer is 3, comma negative 2, comma 1. Hard to do that one in a calculator. You really can't do it. This one, let's talk about if you have all three, what do you do? So what you should be doing is figuring out what combinations can you make in order to make it a two variable equation. So you have to pick either x or a y or z to eliminate. In this case, I'm looking and I see all my y's are similar. So that's probably the easiest thing to eliminate. And I'm going to call this row 1, row 2, row 3. So I'm going to take row 1 and subtract it from row 2. So row 1 minus row 2. So I'm technically multiplying the bottom by negative. So I'm going to do negative x minus 5y plus z equals 17. And then I guess I should plus negative row 2. So I'm going to multiply it by negative 1. So it's going to be 5x plus 5y minus 5z equals negative 5. And then I'm going to add these down. So negative 1 plus 5 is 4x. The y's cancel out, which is perfect. I want that. And then z plus negative is negative 4z equals 17 minus 5 is 12. Okay? So now I got to do another one with a different one. So I'm going to do, I could do row 1 and row 3. So row 1, I don't know why it looks like that. Row 1 and row 3 plus row 3. So row 1 is negative x minus 5y plus z equals 17. Row 3 is 2x plus 5y minus 3z equals negative 10. So I'm going to subtract that down, or add it down, my bad, big add. So it's going to be x, y's cancel out, so give riddance. Z plus negative 3z is negative 2z equals 17 minus 10 is 7. So now I have a two variable equation that looks like this. 4x minus 4z equals 12, and x minus 2z equals 7. So now I can spend my time in figuring out which one is x or z. In this case, I'm going to multiply the bottom by 2 so I could get rid of the z's. Negative 2 so I could get rid of the c's. So it's going to be 4x minus 4z equals 12. And negative 2x plus 4z equals negative 14. A lot of people forget to multiply that end part. So I'm going to subtract or add down. So 4 minus 2 is 2x. Negative 4z plus positive 4z completely disappears, which is good. And 12 minus negative 14 is negative 2. So I figured out that x equals negative 1. Because I figured out x equals negative 1, I could take that and plug it into one of these two equations. I'm going to plug it into the bottom one. So negative 1 minus 2z equals 7. Hopefully you can see after a little bit of algebra, z is going to be negative 4. Now I could take one of the z and the x and plug it into one of my original ones. I'll plug it into the top one. So negative 1 minus 5y plus negative 4 equals 17. 1 minus 4 is 3, negative 3 plus 3, so negative 5y equals 20, y equals negative 4. So my answer is negative 1, comma negative 4, comma negative 4. Here's a word problem, which I think 3 variables. I will not give you that. I'll give you one with 2 variables, but not 3 variables. So let me make a basic one with 2 variables. Ignore this. Let's use something else. So let's say there's adult and children tickets, adult and kids tickets. I know when I sell 2 adult tickets plus 6 kids tickets, that's going to be ending up being. Actually, I'm going to pause and just think of the question fully before I talk about it. All right, welcome back. I just made a question right here, basically a type of question. There are multiple questions. Look at your homeworks for word problems that could work. So in this situation, we have a play selling 2 tickets for adult and children. When 6 adult tickets and 2 children tickets are sold, they made $34. When 3 adult tickets and 2 children tickets are sold, they made $21. How much is each ticket for adults and for children? So in this case, I'm going to make two formulas. When 6 adult plus 2, I'm going to put children, uh, that made $34. And when I sell 3 adults plus 3 children, that makes $21. So what I'm going to do is change that and solve this out. Easiest thing I could do is multiply the bottom by 2, negative 2, so then I could cancel things out. So 6a plus 2c equals 34. And then negative 6a minus 6c equals negative, not 21, but 42. Add that vertically, adults cancel out, which is good for me. Negative 4 children equals negative 8. So then children is going to be $2 a piece. Then I could take children and plug it into either equation. I'll plug it into the top. So 6a plus 2 times 2 equals 34. So 6a equals 30, a equals 5. So adults cost $5 and children cost $2. Um, I think I don't have anything for the ellipse, so I'm just going to tell you in terms of notes how ellipse works. Reminder, you have two types of ellipse. You have the wide ones and you have the vertical ones, okay? So the wide ones are x minus h squared over a squared plus y minus k squared over b squared equals 1. So this one, A is always bigger than B. So let me just say that. A is always bigger than B. So when A is bigger, that means it's more horizontal than it is vertical. You have something called the foci, which is some points here and here on the major axis. A is the distance from the center to the edge. C is the distance from the center to the foci. And B is the distance from the center to the edge of the minor axis. So because you have something like that, you have situations where I might ask you what the foci is. I might ask you how to graph this. So let me make up a question right now. In this question, let's say x plus 3 squared over, let's say 10. No, I need a nice clean square, 16. Plus y minus 2 squared over 25, that equals 1. So the question is here, please tell me what is the foci. So first thing you want to know is your center. To find your center, luckily our center is just h comma k. In this case, h comma k, it's going to be negative 3 comma positive 2. Remember, in the formula, it's negative, so you got to flip the sign to make it positive. Then after that, negative 3 comma 2, what you're going to do is, you know that's the center. Then you have to decide, is it going to be more long or more tall? In this case, since this number is bigger underneath the y value, it is tall. So now I know from negative 3 comma 2, I am going up and down from that center point. So I'm going up and down. Now I need to find the c value for the foci. To find the c value of the foci, it is a squared minus b squared over equals c squared. So almost the Pythagorean identity. Remember, a is the bigger number. So in this case, it's 25. So 25 minus, well, 25 equals a squared. So a equals 5, which means a squared is 25. B is 4. B is 4. So it's going to be 16 equals c squared. 9 equals c squared, so c equals 3. So since I'm going up 3 and minus 3, or down 3, that means my two foci is going to be going up 3, negative 3 comma 5, and going down 3, negative 3 comma negative 1. If I was going left and right, I would add it to my x values. I'm trying to think what else you need to do. Oh, if you needed to graph this, I guess this is continuing the same problem. So that's the center, that's the foci. I should say you have two major points and minor points. So I'm going to call this the major vertices and the minor vertices. Why do you do that? So the major vertice, major. The major vertices and the minor vertices. In terms of the ellipse, this is where they hit at the edges over here and where they hit at the edges over here. So the major vertices, it is a distance away from the center. So my major vertices is going up and down from the center, which in this case we could figure out is 5. So my major vertices is going to be negative 3 comma 7, because I would plus 5, and negative 3 comma negative 2, because I would go down 7, or go down 5, which is not negative 2, but negative 3, because 2 minus 5 is negative 3. My minor vertices is going to be going left and right, because my x is the smaller of the two. In this case, it's going to be my b value, which is 4. So my minor vertices is going to be minus 4, so negative 7 comma 2, and then plus 4, so positive 1 comma 2. You have these points here, so now you could kind of graph. I'm just going to be a very basic sketch right here, where I know my center is negative 3 comma 2, so somewhere down here. I know my major vertice is going to be, I have it here, negative 3 comma 7. So up here, and negative 3 comma, oh, I messed up the graphing so bad. I apologize. It's negative 3 comma 2. So it should be up. Why do you do this to me? So it should be up here. So negative 3 comma 2 should be up here. So I'm going to go up 7, or to negative 3 comma 7, down to negative 3 comma negative 3. And then my minor vertices is going to be, in this case, plus or minus 4, so it's over here. So it's going to be negative 7 over here and positive 1 over here. So I make a general oval shape. My oval shape sucks because I didn't do this on an actual graph. And your vertices are going to be on this graph, where it's going to be on here, which is on the major axis. And it's going to always be inside the parabola. Okay? That's the basic overview of ellipses. Look at your notes or homework for more help. Or Google stuff, I don't know. If you want to Google it, it would be called conic sections ellipses. All right, good luck with everything.